Okay, 37. This one was not tricky, but you had to read carefully. Zeke and his 6 friends are going to the baseball game. Their combined money that they have totals $28.50. At the game, hot dogs cost $1.25 each, hamburgers cost $2.50 each, and sodas cost 50 cents each. Each person buys 1 soda. They spend all of $28.50 on food and soda. Write an equation that can determine the number of hot dogs X and hamburgers Y Zeke and his friends can buy. So let's talk about this for a second. They tell you in the problem that each person buys a soda. Well, a soda costs 50 cents each. So let's go ahead and solve or evaluate how much money was spent on soda. Here's the tricky part. Zeke and his 6 friends. How many people are there? Not 6. There's 7 people. It's Zeke and his 6 friends. There's 7 people. So you're taking the 7 people and multiplying it by 50 cents. That will give you a total of $3.50. So Zeke and his friends, they spent $3.50 on soda. Now we need to find out how much money do they spend on hot dogs and hamburgers, X and Y. So it costs $1.25 for a hamburger. And it costs $2.50. No, I'm sorry. It costs $1.25 for a hot dog, $2.50 for a hamburger, and we're adding on the $3.50. This, all of it should equal $28.50. Now, why am I equaling it and not like making an inequality? Because they tell us in the problem that they spend all of it. So that's why it's going to be equaling that, okay? So write an equation. That's it right there. You could write it as that, or I like to simplify it. In this simplified version, it's y equals negative 1/2 x plus 10. This is also correct, or the top way is also correct. You could just convert this garbage into the y equals form of a line. And you'll see right now why I did that. It says graph your equation on the grid below. Easy peasy. Now we just converted it to a negative 1/2 x plus 10. Let's go ahead and do it. So on the side here, since this is the y-axis and they tell you that hamburgers is y, this is going to be the number of hamburgers. Okay? Down here, this is going to be the number of hot dogs. Okay? So, I'm just going to count by ones again. But I'm only writing the 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Now, over here, did I also count by 2's here? I think I did. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so I am going to graph negative 1/2 x plus 10. So it starts over here. Let me get a different purple. So it starts over here, and you're going down 1 to the right 2. But you got to be careful here, folks. Got to be careful. For every 1 hamburger, it goes over 2 hot dogs. So that's why I counted by ones here as well. So down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. Keep on going. So you get down to the very end, down here, okay? That's your line, folks. All right, so this is the line of this graph. So here all the way down to here. Let me make those points a little bit bigger, and you'll see why in a moment. Okay, so this is the line that we have. Okay? That's it. Then it says, oh, and you could label too. Y equals negative 1/2 x plus 10. So for the second, or for the third part of this, it says determine how many different combinations, including those combinations containing 0, of hot dogs and hamburgers Zeke and his friends could buy, spending all $28.50. Explain your answer. So the key word here is combinations containing 0. Okay, meaning that everyone could buy a hot dog and no one could buy a hamburger, or everyone could buy a hamburger and no one buy a hot dog. How many combinations are there? Well, you just count the dots, people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 combinations. Some of you might be asking to yourself, well, how about the ones that are in between, Trevor? No. The problem is, let's just say you get one hot dog. That is 9.5 of a hamburger. There is no concession stand at a baseball field that will serve you 9.5 hamburgers. They will give you a full hamburger. So that's what they were testing you on. And I know it's kind of dumb. Well, actually, it's not that dumb. But just know that you just count up all the dots, and there's 11 combinations. And as you can see, this dot up here has all hamburgers, no hot dogs. This combination down here has all hot dogs, no hamburgers. So either you could get 10 hamburgers with no hot dogs, or you could get 20 hot dogs with no hamburgers, or you could get any of this combination in between. So to explain it, you're going to say 11 combinations. Now here's the explanation part. Because only $25, which is the result from $28.50 minus the $3.50 spent on soda. So they could only spend $25 on food. So only $25 can be spent on, here's a key, whole products of hot dogs and hamburgers. The line above, well, on your readings it's above, on this is the previous slide. The line above shows 11 possible points where the combination would work. And that is how you do that final question.